All right, welcome to Service Mesh Academy for August 13th, 2026. It feels really weird to say August and 2026 in the same sentence. We are here today to talk about mesh expansion onto Windows, which is to say, making your Kubernetes cluster running Linkerd play nicely with things that are running on Windows. With me here is Kashif Hassan. I apologize if I got your name wrong. Who has been the one over at Buoyant wrestling with Windows and making all this stuff work. So take it away. You want to say a little bit about who you are and all that, and then we can get into the presentation?
Yeah, absolutely. I'm a developer here at Buoyant, and I've been working on the Windows Mesh expansion solution for a little while now. It's been a project. It's been a fun project that we've just gotten to an alpha stage, and we're making externally available for our customers now. I've been working on various bits of software for a long time. I actually started my career at Microsoft writing Windows kernel-mode drivers and working on the development test team there in the Windows device group many years ago, and happy to be here and present this Windows Mesh expansion solution that we've developed here for you, for all of you.
Excellent.
So let's just get right into it. What are we talking about? So just a quick overview of what we've got on the agenda. We're going to have a little discussion of what we mean by Windows Mesh expansion, kind of how it works. We're going to take a look at the public-facing installation guide that's available on Buoyant Doc's website. That'll give you all the details for setting up your own solutions, and we're going to do a demo of Windows of expanding a cluster into using workloads on Windows virtual machines.
Which is pretty cool, actually.
So if you all want to follow along, there's several links here. The first link is the public-facing doc for the feature overview itself. It's a very high-level discussion of how to set up Windows Mesh expansion and what the requirements are. The install guide that follows after that goes into a lot more detail. We'll take a look at that about a baseline profile that we verified ourselves that works in our network topology, and obviously there'll be other requirements for all of you to run on your networks and in your cluster. There's a playbook for the demo that we've done, which details all the pieces, how they're set up. We're using Azure AKS clusters and virtual machines to show this demo. So some of the implementation is specific to that, and obviously can be modified to your requirements. And we're going to be using the Bell, the Enterprise Edition 220.1. We first released Windows Mesh expansion in the 220 release, which added support for Windows Server 2025 versions of the Windows operating system. And in the 220.1 release, we've expanded that to include Windows Server 2022, which is also what we'll be demonstrating that.
Just in general, there are things, if you're running Buoyant Enterprise for Linkerd, 2.20.1, yeah, you should go ahead and upgrade. Don't run that 2.20. Do not run 2.20.0, run 2.20.1. It's a nicer release.
Yeah, get on the release train.
Yeah.
And obviously, if you want to set up your own Bell cluster, you'll need to get unique user ID during installation for the licensing, or get a free ID from our website.
And we promise we will not send you spam or sell your email to horrible people or anything like that. It'll be fine.
That's right.
Also, if you have questions, then the chat in the webinar chat here will work. But you can also go and join the workshops channel on our Slack, which is slack.linkerd.io. that's the best way in general to get questions to us, if you have any.
So I mentioned a couple of requirements that we'll need for doing this demo, and then that you'll need to follow along. Let's go into them in a little bit more detail. Obviously, you're going to need a Windows host. We're doing Windows mesh expansion, whether it's a virtual machine, whether you're running on VirtualBox, VMware, Hyper-V, or if you've got bare metal that you're running on, if you're running on a hyperscaler, you're running your own solution, it should all work. We've tested across many of these variations and don't know of any issues. And you're going to need a cluster to talk to, obviously. And the two are going to have to be able to communicate to each other. And the network's going to have to be able to be routable to the pods from the VM and vice versa.
You said to the pods, so the VMs need to be able to talk directly to the pod cider, not just the service cider, or do they need both?
So we're actually using in the cluster, we're using internal load balancers to handle that level of routing. The harness does reach out to services in the cluster, 3 of them specifically that we'll go into, and that's required for bootstrapping the entire solution.
Cool.
And we'll need some DNS resolution. We're going to use core DNS during this demo. That's not a hard requirement. You can use whatever solution that's appropriate for your networking. Oh, and I should mention also, Spire is a hard requirement. The Windows VM, in order to do identity attestation, will require a Spire server, and the VM running that's being expanded into the mesh will need a Spire agent. So, and we'll talk a bit about how we've set up identity and are keeping secrets secure in the cluster and managing that attestation as we go through the demo.
Within the Kubernetes cluster, we use Kubernetes service accounts. There are no Kubernetes service accounts outside the cluster. So if you want workload identity, and you do because it's required and you want it anyway, you have to be using Spiffy IDs outside the cluster. So, yeah.
And it's important to note, I'll say this at this time, while it's a hard requirement, it's not something that's included in our installation.
Right.
The installation itself, so it's required for you to have that set up prior to installing the Windows Mesh expansion solution, and we'll see that all in action here shortly. And obviously, the last thing we need is kubectl to control the cluster. Things going on. Okay, so let's talk about what mesh expansion is. Buoyant said support for mesh expansion for quite a while now for US State observers of our product offerings. You all know that. It gives the opportunity.
16? I'm not sure I remember which one it was.
I think it's 2.15. I think alpha in 2.15, but maybe didn't go a general release until later. But it's a way for VMs or bare metal devices or edge devices to collaborate with all the services going inside the cluster and join the mesh. And it brings a lot of benefits to this functionality. Brings a lot of benefits for legacy workloads or edge devices that can't be containerized and put in a cluster to still be able to get all the benefits that come along with the service mesh. And the way it has worked before is the Linkerd proxy runs on the virtual machine or the host system that's being expanded to, along with a harness application which bootstraps several things within the cluster and manages identity, auto registration, and responds to ready probes and things like that to maintain a healthy work state between the workloads that are being meshed.
If you look under the hood, you actually find that the mesh expansion stuff basically amounts to run the Linkerd proxy and then set everything up pretty much the same way Kubernetes would around it. It's kind of a cool thing, really.
Yeah, the idea is to carry forward a lot of the same configurations, and one of our goals throughout this has been to make the installation and setup fairly simple as we can, but still give you the flexibility to configure the various settings for what's appropriate for your network topologies.
Yep.
And today, what we're talking about in this MSA, this Academy, is our expanded solution for Windows Mesh Expansion, which takes that same level, builds on top of that platform that we had already for a mesh expansion solution, which only ran on Linux, all the way to Windows VM and bare metal devices and edge devices. And obviously, the benefit that this gives us is the ability to access Windows workloads from the cluster.
I should probably point out we say a lot of things like VMs or bare metal, or the fact is that mesh expansion doesn't know what you're running it on. So knock yourself out. Whatever works for you, if it's a Windows host, mesh expansion should be happy with it.
And one of the challenges, one of the interesting bits of this, why this hasn't been done years ago, is basically because of a difference in the networking stacks between Windows and Linux, and maybe it's worth taking just a second to talk about them. The Windows networking stack doesn't have an equivalent level of redirection functionality that Linux does via IP tables, and its broad rule set of being able to redirect ambiguous connections from previously unknown ports to other ports, and that's been a blocker for I think many implementations of service mesh attempting to get onto Windows. We resolved that by writing a custom Windows kernel driver that hooks into the networking stack that provides creates that level of functionality, and getting that driver validated and digitally signed by Microsoft so that you can load on your production Windows systems without any issues.
Which I understand was a source of much personal delight for you.
We'll talk about all of that over a beer after the Special Academy fun. But I did make it through, and we do have Windows certified drivers at this point.
Which, to be clear, is important, because if you don't get them certified by Windows, things don't go very well.
That's right. It's still possible to load uncertified kernel drivers in your Windows system, but you have to,
for the moment,
do certain things like disable secure boot and trusted computing platform, and you don't want to be doing in your production environments. So
if you just let's just stay away from that.
That's right. Okay, so this allows us to do a couple things that we never were able to do before using Bell, and we're able to create mixed environment networks with both Linux and VMs or edge devices working alongside of clusters, which we think will unlock some workloads. We have some customers already that are very interested in the functionality. So looking forward to engaging with any of you out there who also have a need for these abilities. And let's talk a little bit about how it actually works. So we talked about the proxy client. This is the same Linkerd D2 proxy that runs in cluster, runs on Linux Mesh Expansion. It already has been running in Windows. with our Windows container support, which we shipped last year. And now we've brought it to Windows host. It's completely unchanged as far as adding specific functionality for Windows. It's built on the same Rust code base and compiled for Windows, just like the containerized version was for Windows container support. We did make several updates to the harness, though, to add Windows support, integration with the Windows Service Control Manager, some updates for logging, configuration, and the registration with the driver that we talked about. And the biggest piece of this, again, is the actual kernel driver that does the network redirection. And it's worth talking about this for just a second as well. The kernel driver has one task. There's one gap that we talked about with IP tables versus that implementation on the Linux side that Windows doesn't support. So this kernel driver fills that in. It redirects certain outbound TCP connections to the proxy. So the proxy can do all of magic, apply identity, policies, make routing decisions, all of that. It's select outbound connections because there is an ability to ignore certain ports, which can be configured during the installation time, can be modified afterwards if you need to. And the driver always ignores connections originating from the proxy and the harness themselves for obvious reasons. We'll just mention that this is all built on top of the Windows filtering platform. If you're a Windows kernel developer or knowledge about the internals of the networking stack, that's a filtering platform, as the name implies, within the Windows networking stack that allows you to do, that's mostly designed for filtering, but does allow you to modify network traffic as well. And you take advantage of the application layer enforcement capabilities to do that redirection on the outgoing network connects, as we talked about. And all of this is packaged up together, as we'll show in a MSI installer. That's a Microsoft Windows installer, and we're providing a version of that along with every build of Bell with versions of which has embedded inside of it versions of the proxy and the harness associated with that release. So we already have a full pipeline up, and these builds are, as builds continue to be released, there'll be new versions of this installer with the updated binaries.
There's a question in the chat, actually, that I'm going to jump in with for a minute. Does the kernel driver install a virtual interface, or does it not? You can tell which of us actually knows anything about Windows here, huh?
Yeah. So the kernel driver is a WFP callout driver. And what it does, it installs as a system device to load at boot time. It registered with the WFP engine, the Windows filtering platform engines, and registers one specific callout, the connect redirect callout. And as network connections come in, it applies a set of rules to determine if it should redirect that connection. The harness, when it starts up, it registers with the kernel driver, providing the PID of both itself and the proxy. And that's how we determine which connections are redirected.
But it sounds to me like if you list all your network interfaces before and after starting the driver, it's going to be the same set. You don't have to worry about all your traffic going through some magic interface. We just grab anything.
We're not modifying the network interfaces on the system at all. The callout driver, exactly what it is a tiny bit of code that runs in the kernel in the networking stack. And as connections are coming in, our driver gets called, we modify the connections we need to, and we send them back on their way. So there's it's transparent from that layer.
Cool.
And we'll be showing that as we go through this demo.
All right, onward.
We're done too. Before we get into the demo, we're going to take a look at the installation guide. There's a couple of things I want to point out to you that are explained in greater detail in the installation guide, but we won't be going through in the course of this demo. So let's take a look at that right now. As here we go. Okay, we are looking at the docs.buoyant.io website, and you'll see under our list of guides, we're down here at the bottom, installing Windows Mesh Expansion, WME is what we've been calling this feature.
Mm-hmm.
And right now, I want to point out, as we go through this guide at a real quick high level, I'll point out that the set of documentation is for the 220 release. As we've already talked about, we have released 220.1. So the supported platforms listed here are actually out of date already. We've added support for Windows Server 2022, which is in its matrix, and this doc will be updated as we release the next version of the next major version of Bell. And quick note about the prerequisites. We've already talked about the ability to route to services in cluster. These are the 3 services that the harness relies on before bootstrapping the proxy. So these must be routable by default. We're using a set of default DNS names and ports to access those, but these can be overridden and customized for your implementation.
Those are actually the same names that Linkerd inside Kubernetes gets. Well, sorry, the destination and policy. Those are the same names that Linkerd in Kubernetes is using as well. So
yeah, if you haven't changed this in your environment, you probably don't need
really to, probably don't want to mess with it. Yeah. Yeah.
There may be there's probably a lot of scenarios, especially multi-cluster, in which you have modified these. So if you do need to do that, you do have the capability within the MSI installer that we're going to show.
The most common change would be, as your docs mentioned, they're changing the cluster domain, and
that's right.
You might run across that.
Yeah, and as I'll show you just in a second, if you only change that suffix, you can just specify that once, and all the other defaults will just correctly derive their full DNS names from just applying the custom suffix. Mm-hmm. We already talked about Spiffy and Spire. This document goes into a little bit, and it details a pattern that we've been using, which is using an intermediate certificate on the Spire server, and keeping the root CA in cluster, using a path on one on the root CA, and creating a bundle to from identity. That's way that root CA never needs to leave your cluster.
Yep. I'm going to call out one other thing in the docs that I had not heard before now. The Spire agent must be running on the VM before the MSI executes.
Technically, that's true in order to avoid seeing errors in your in the harness logs. If you bring it up afterwards, things will work as you expect them to once identity is established. But if you look at your harness logs, you might see a bunch of errors and timeouts in the meantime.
It's going to be easier just to have the agent running first.
Yeah. Windows Firewall has its own set of configurations. We're not going to presume to know exactly how you've got yours set up, but there are certain things that you have to make sure that the virtual machine has access to incoming traffic that's coming from the control plane. However, we've configured that up, that the proxy is able to receive inbound traffic from the cluster on control port as well as its admin port and respond to the readiness probes that come in. So we'll be showing that in the demo, and obviously this is specific to your network environment. Just like the existing harness mesh expansion solution, we rely on an external group resource being created in the cluster in order to actually register with the auto registration controller and provide those workloads. This is an example of doing that, and obviously will need to be customized to your workloads. The installer.
There's a lot more information about what is really going into the harness and what it gets for you, what it offers. There's a lot more information of that in some of the earlier SMAs. The functionality of the harness, as I understand it, doesn't change at all between Linux and Windows. It's all about giving your cluster a way to figure out which external workloads are really available at any given moment.
Yeah, if you're very familiar with how the existing mesh expansion solution works with the harness, essentially there's a configuration file which defines the harness behavior. And we carry that format entirely forward. We introduced one new field in it to enable Windows mesh expansion, but all of the same values are able to be customized and updated for your deployments. The installer itself only has a couple required fields that aren't filled in with default values that we think are appropriate for most environments. The IP address of the machine that you're actually running on with the adapter that you're expecting connections to come in from needs to be provided during install time, as well as the external group and namespace that you've created in order to provide that workload into the mesh. So a standard install would just provide those values, those three values, along with calling the installer however like you want to configure it for logging and observability. But we do provide a rich set of properties that you can use to override the default values. The full table is provided here, and this is mostly what I wanted to show in this piece of the walk through the install guide. Again, those three required fields are listed right here, and there's a set of other fields that can be customized. I'll go through them real briefly just so that everyone's aware of what they are. We talked a bit about the in-cluster services that the harness needs to speak to. So if you have custom addresses for those, this is how you would specify them. Or if you just add a custom suffix, you could change that right there. You get to specify an install folder if you don't like the default. The default is in program files, Buoyant Linkerd. This is the control server name. It applies to the other service addresses listed above. Spire has a default name type for a socket address, and again, that can be customized. If you want your logs to go to a different folder than the install folder, if you're trying to optimize for where your logs live, there's no mechanism right now for rolling the logs over, truncating them, anything like that. All of that has to be managed outside of what's installed through the solution. And this gives you the ability to customize that as you see fit, and obviously change the log level. We default to an information level of logging in both the harness and proxy. And by default, we have a couple values for the inbound and outbound ports that the proxy is using to connect to the cluster. And if you wish to avoid to have any traffic specifically not redirected by the driver, you can specify a list of outbound ports to ignore, which will get written to the Windows registry and parsed by the driver when it starts up, and it'll honor those port numbers. So if you have any traffic that needs to be exempted, by default, we use port 8081, where the Spire agent traffic goes. It could be redirected, but it doesn't really make sense to go through the process.
It feels like if you redirect traffic to Spire, then you run the risk of things getting confused during Bootstrap, but
you would. We already have an exclusion rule in the driver that specifically excludes both the harness and the proxy traffic, so it would work.
Yeah.
But
okay.
You just add an extra layer of redirection that doesn't accomplish anything, so we ignore it by default. And if you have other traffic that falls into that pattern and you need to modify this list, there's an ability to do that within these MSI parameters. The rest of the document gives a few post-install configuration options. One that's important that we'll go through in the demo is setting the installer will install the Linkerd proxy harness service in the Windows installer, but it won't set up the dependency chain of how these services should start on boot. And the Spire agent installation is completely outside of the MSI, and if you've named it something other than what we have as our default values, or even if you haven't, you'll want to set the dependency chain appropriately so that so things start up in the correct order on boot in Windows, and you're able to. If you don't do this, there's a set of retry mechanisms built into both the lifetime management of the proxy and harness. They'll probably recover from them, but that can be a timely process. So this is an optimization that's worth doing. And we've got some instructions to verify the installation works. As you expect, we'll go through those during the demo. Uninstalls, clean up the system just as you would expect. And I believe we've got some troubleshooting steps in here. If you'll find difficulty during the installation, we'd love to hear about it, get any feedback that you have so we can continue to improve the offering and address any issues that might appear in the field. But there are a set of diagnostics available. Again, this is a complicated system, so not inconceivable that you'll have to go through some of these steps in the process. Okay, with that, let's see. Let's go back to, I think we're ready for the demo. So let's go right ahead and jump into it.
So
fingers crossed. We all know how tech demos live go, but
shall we talk about what you're running for the demo, or do you want to do that a little bit later?
Let me show you a few things. that I've got set up. And
Cool.
then I'll let you jump in, Flynn, as we talk about the actual demo. So let's see. Like I mentioned, we're using Azure, and I've got a very slow Azure command line.
I mean, that is part of doing a demo, is that all of your commands run more slowly.
Yeah, amazing how that happens, isn't it? There we go. Okay. I've got a couple of VMs set up in Azure, running Data Center Edition. We'll come back to the IP addresses and the tables, but I just want to show you, we've got a few though. We've got a VM just for running the Spire server, where the secrets will live. And then we've got separate ones, 3 separate ones for running Windows Server 2025, 2022, and 2025 core. We'll go through all of those here shortly. And we've got a deployment in the cluster set up already. Let's take a look at that. We've got the Faces demo, which you astute followers of the Service Mesh Academy have certainly seen before. But what you'll notice is that we've scaled it down. So neither the color nor the smiley service is running in cluster, but the face service and the Faces GUI are. Flynn, do you want to talk a little bit about?
Yeah, we can do that really quickly. Hang on a moment. Everybody cross your fingers while we switch screen shares. The Faces demo is one, as you heard, we use this a lot. It's simple, but it's still using microservices in a way that requires a bunch of things to work correctly. The way this thing works is that we have a GUI running in a web browser. The GUI has a bunch of cells on it. Each cell is going to make a call to the Faces GUI service, which is normally running in a cluster, but I don't think you have it running in a cluster right now. The Faces GUI will then turn around and make a call to the Face workload. Face makes an HTTP call to Smiley and then a gRPC call. Well, sorry. At the same time, it makes an HTTP call to Smiley and a gRPC call to Color. Smiley is responsible for returning a smiley. Color is responsible for returning a color. That grinning smiley face and this blue color are when everything is working correctly. The Face workload comps those two together, and then that's what the GUI displays. If you go to the GitHub repo there and you just install with the Helm chart, you will get an installation of Faces that is not set up to work correctly. That is intentional because this was originally a reliability demo. Don't panic. There's also instructions on how to make it work much more smoothly in there as well. But as you just heard, in this demo, color is not running in the cluster anymore, and the GUI is not running in the cluster anymore. Do I remember that correctly?
So I'm actually going to show a couple of things. So right now,
excellent. I'm going to go ahead and let me take this down and then switch back to your screen share, and then. The important thing here is that you just looked at a diagram that has everything running in a Kubernetes cluster, but that's not what we're going to see running.
That's right. So right now in the cluster, what we have is the Faces GUI and the Face service, but we've scaled down Color and Smiley. So, and I'll show you that in just a second. What we're going to do is bring those two services up on Windows Mesh expanded VMs and see that working. Then we're also, hopefully we'll have time, we'll switch to using a Faces GUI that's running on a Windows VM as well. And we can show the outbound leg of that, application on the Windows Mesh reaching out to services in the cluster, which actually reach back all the way to services running on Windows VMs. So show all aspects of all of this working. That's the plan.
Excellent.
And let's take a little bit. Let's look at what we've got as far as pods. We've got, like we mentioned, the face service and the face GUI running in cluster already. And just so you can see, I will show you that there's no created external groups or workloads right now. And let's take a look at
And
this.
if you've seen the service mesh expansion on Linux, you will know that external groups and external workloads are pretty important.
So as Flynn mentioned, right now, this is our in-cluster face GUI, and we see a little cursing face and a blank background color indicating that both the smiley and the color service are not working. And we'll go through and do the bring up of the first piece of this, which will be getting smiley working on the Windows VM. So we can do that beautiful smiley face. And we talked a bit about the load balancers. Let me show you that right now. So in the cluster, I've got load balancers in front of these services, the three that I mentioned that need to be hit by the proxy so that we can route to them. DNS, so we can get names out, and the face GUI just so we can, so all of you can see it. And actually, I meant to do this, which was give you all this URL, which is, as you'll notice, this IP address is this one right here, is the faces GUI. So if people want to follow along, that should work. You should be able to see this in real time as we bring up the Windows services. Okay.
So one thing that, hang on a second while I look at some of these. Yeah, so you had to create some of those load balancers for destination and policy, right?
I did. I created them. Okay. Yes, I created them all.
Is that something that automatically happens with the Windows harness right now, or is that part of your demo setup?
That's a manual step, and there may be other patterns that are more appropriate depending on your cluster setup, but this is one that we've proven as a
the thing that I kind of like about this is that it implies that you only need access to the service siders and that you could conceivably do this with less network access than we normally have. And that's kind of nice. Most of the time that I've done this, I have deliberately set up the Linux hosts so that it was a flat network configuration and a process on the Linux host could speak directly to a pod in the cluster, which is handy in some ways, but obviously a little bit limiting in other ways.
That's right. So let's go ahead and we'll start by taking a look at the Spire server that we've set up, just so I can show you how that's working. Again, this is a VM that is just running the Spire server. It's not running mesh workloads, but we rely on this for identity attestation.
Yeah.
And let's see, what I want to show you is what's been bootstrapped here is there's a bundle that we've created that is an intermediary between the root CA and a key that's on this machine that we're using that's going to be used on all of the meshed VMs. And that contains two public certs. So the Spire upstream CA can be used to verify the agent with the Spire server. And we'll use join token, which I'll show you here in just a second. Okay. There's a few commands I want to run to show you what's going on this Spire server. So we've got a running server. We've got a couple of certs, this bundle that has the root and the upstream CA, and these keys and certs that are that stay on the this VM that are not the root CA. And I can show you that there's no entries right now, and there's no agents tested. That's what we're going to go through and do.
I'm sorry, could you back up a second? You said that CA.cert and CA.key are not the same one that Linkerd is using for a trust anchor. So you just created those yourself, right?
That's right.
Okay, so that's also not the one Linkerd is using for the identity issuer. It's
that's right. That's in cluster. So the bundle
between the cluster at all, right?
Exactly. So that root CA never leaves the cluster.
Awesome.
Okay. And what I want to do right now is create a new entry on the Spire server that we're going to use on the Windows VM to establish identity. So we're going to give it a name, a parent ID, and a SPIFFE ID, Smiley, and we're going to use the Windows system account. Again, if you're running under a different account, this is something that you'll have to manage for your network configuration. Great, we've got a new identity created, and now what we need is a short-lived token so the agent can do attestation with the server, the agent that we're going to install on the Windows VM. So we're creating one with a timeout of a couple minutes, and let's save this token off because we will use it in just a minute. And then let's go over to a Windows VM that I've got running already here. We've got a couple things staged on here that I will show you. I can already see them in my command window, but just to be completely clear. So if you've cloned the repo for this SMA already, you may recognize some of these files. This is mostly the other set of scripts from the repo that are meant to aid in this installation of all the services we need to, I'll talk to some of their configurations. These are all available as references, but obviously the agent and server configurations will be specific to your environments, as well as how we're installing Spire. I'll talk to a bit about how those configurations are set up. These two files here are not in the repo. These are parts. These come from the Windows development kit, and they're tools to pull log files out of the driver. The driver has a separate logging mechanism than the harness or the proxy, and it may be useful for if you run into issues during deployment to be able to access these logs. So I'll show you how to do that as well. But really what we want to do is execute this Spire script, which is written to bootstrap the agent and attest to the server. So let's do that. We have to provide just a couple of things: that bundle that we showed you, the server address, and the token that we just created. And this will take hopefully just a minute. It downloads a version of Spire. It wraps, creates the Windows Service Wrapper template that it uses to install that agent as a Windows service, and it creates the pipe workloads and bootstraps the agent already up. Script setup worked. Great. And we can test this by going back to our Spire VM. Sorry, wrong VM.
This is the challenge of doing all of this with VMs in Azure.
That's right. Now, when we look at the agent list, we'll see the one
Untested agent.
agent joined. So that's working just like we expect.
And for those of you who are not intimately familiar with Spiffy and Spire and attestation and all that, there's a fair amount of reading to be done here. But broadly speaking, attestation in Spiffy terms boils down to having something that can vouch that you are who you say you are. And it's a critical part of working with Spiffy.
The next part of this that we need, the next prerequisite we need in order to do the installation is the DNS names. And so we're using core DNS. We've got a script that's specific that's got some Azure DNS name servers in there as default. There's really nothing else specific to Azure, and you can be modified for your services. And the way we'll execute this script is by passing in the in-cluster IP addresses for the load balancers for those services that we're interested in. And this script will download core DNS and set up a core file and register these. So we'll run that. And core DNS takes a little longer to download, but we'll go ahead and watch as this happens in the Windows PowerShell. It just take not that.
It's always DNS.
Okay.
Actually, that's not that bad.
All right, so we're seeing already that our script bootloaded, got us set up with a DNS server, did our resolution check. It's able to get the appropriate address. Also looking good. And as we talked about before, we've got a couple Windows firewall rules that we need to create in order to get inbound traffic from the mesh to the proxy that we're going to install on this VM, and also for metrics. So I'm going to add those Windows firewall rules right now. That's what these two are, inbound mesh and good proxy metrics. Okay, so our VM now has all the prerequisites in order to be able to do mesh expansion. On the cluster side, we need to create an external group. We create a policy to apply an external group and to get that workload to bootstrap the auto registration process for that workload to be visible in cluster. So I'm going to go back to my Windows host and run a kubectl apply command to do that, to create a in the faces namespace, create a smiley VM external group and set up the routes and the nothing else really important to say here, I don't think. That's not expected. Let me fix this real quick.
This is how you know we're doing it live.
I think there's just an extra. Okay, added an extra dash. I should have. Let me try that again. Let me fix this real quick. I removed a dash and I should have. Okay, much better.
Excellent.
I love live demos, don't you?
Yeah. And again, if you've seen this before with Linux, then it's worth pointing out that to use an external group, you have to be running Buoyant Enterprise for Linkerd so that you can have the harness going, et cetera, et cetera. So this is why we're using Buoyant Enterprise for Linkerd, right? Go ahead.
Yeah, that's right. And let's see what we just created. That's the external group and workload that we just created. The MSI is not installed yet, but the cluster is ready for it. And what we're going to do next is actually install that Smiley service on the Windows VM before we install the Windows Mesh expansion solution, so that the service will be ready as soon as the cluster is meshed, and as soon as the VM is meshed to the cluster. Well, let's hop back to our VM, our Smiley VM. Oh, and I never created this last firewall rule. The enter key there. And one more script to install the Smiley service. As of the latest release of the Faces demo, we have Windows support. Thank you, Flynn. And we're downloading those binaries directly from the GitHub release page, wrapping up in the Windows Service wrapper template, installing it as Windows Service, and all of that has executed. Great. Still, nothing but cursing faces in the UI because we haven't actually meshed yet. So that's our next step. Let me get back to the right VM. Okay. So first thing we're going to do is just download the MSI. You can see that we're grabbing this right from our release, our GitHub release page. We're grabbing the 220.1 version of the MSI, and just that easy. And now we're going to install it. We're going to install it with the 3 fields I told you about: the IP address of this machine, and the group name and namespace that we just created. And we've got, let's see, we're installing in quiet mode. That's fine. We'll take a second. And let's see, how are we looking? Do we see? Not yet. Sorry, let me grab the correct VM. And let's take a look at the services installed. Let's see if this happened correctly. Okay, so both the harness and the kernel driver are installed and in a running state. That's good. we should actually be seeing smiley faces already. Oh, there they are.
And there we do. Hey,
That's nice.
when in doubt, give it another 10 seconds.
Yeah. Okay.
But this is pretty cool because you've got the face GUI and the face workload running in the Kubernetes cluster, reaching out over to the Smiley workload running on a Windows box, which is cool.
Yeah, exactly. We were able to, and you saw how mostly quick that installation process was. We ran
I'm
it.
sure we get to redo it with color, right?
That's right. We're going to go through it again on Windows Server 2022, so we can show the backgrounds come up. And let's see. There's a few things I want to show on this VM before we leave, just to show you exactly what happened during that installation process. And the first thing I want to show is, let's take a look at that harness config file that we talked about. This is a big JSON file. And a lot of those values that we talked about during the install time are generated by the installer using its default values, or the ones that you've overridden with the MSI properties will create this harness config file to define how the harness bootstraps the proxy and connects to the cluster. If after installation time you need to modify any of these values, this is a text file on the system that can be modified. We also provide a harness CTL tool, which can be used to modify the group name and group namespace that are defined here in this in the config file. So important bit to know of just how this is tied together and how the pieces work. The other bit I wanted to show you is the Windows Device Manager. I've got it open up here, and we can see now under System Devices, we have a Buoyant Windows TCP redirector for Linkerd installed. That's the kernel driver we talked about. If we open it up and check out the driver details, we can see that we're running on version 1.3 of this. That's our current release, and that has been signed by the Microsoft Windows Hardware Quality Labs. So what we've shown already is Windows Mesh expansion, adding that Smiley workload to this Windows Server 2025 system. Let's see, anything else worth showing you right now? There's a question in the group chat I see about it.
The shortest answer to that question is that you should still be able to get pretty detailed observability via the metrics on, say, HTTP route and gRPC route and things like that. Viz will not directly show you an external workload in any of its graphs. I have to be a little bit careful about this, but there is work going on to improve this situation for Buoyant Enterprise for Linkerd, and I think that is going to be your best. I think that keeping an eye open for that's your best option here, because some of the stuff in that new project I'm actually really looking forward to, and I think that I think it'll do external workloads natively. I will have to check.
And going back to the cluster, I want to show that external workload now that we've installed Windows Mesh expansion. You can see that that external workload has been registered with its Biffy ID. You can see the time we created it. And we can see when we get the endpoint slices for the Smiley service. You can see the in-cluster service that's been scaled down is unset, and the new one that we've added from the external workload is available. So just
Right.
like we'd expect.
There's one, I want to point out something here. The one on the second line, smiley -q, et cetera, that is actually being created by the service controller in the Kubernetes cluster, which is coming up and going, oh, hey, there are no pods here, so I got nothing. The Linkerd external smiley, et cetera, is being created by the Linkerd external workload controller, and it knows how to find the endpoints so the right thing happens. The distinction is kind of important there because you will see both. It is expected that only one of them will have endpoints. This is completely normal, and it has to do with the way the controllers are working under the hood. If you want to know why we can't just turn off the service controller for that particular workload, that's a much longer discussion. And yeah, that one should involve alcohol too. Yeah.
Good clarification. Thanks for that, Glenn.
There's also the Linkerd diagnostics endpoint command, which will also give you good information here. But I actually really like that these show up as endpoint slices. It makes a couple of things a lot easier.
So we've got halfway through our demo. We've got smiley faces, but let's bring up color on the Server 2022 VM. We can see that as well.
And for this one, I figure it might be worth just try to run all the commands and let's see how long it actually takes.
Exactly. Yeah, we won't have to do quite so much talking through what's happening. We can just go ahead and just breeze through all these scripts. So let's go. So we're going to start by going back to the Spire server, creating a new entry for the color workload and a new temporary token that the agent can use for attestation. And I'm going to save that. And on my, let's clear this up. On my Windows Server 2022 VM, I've already got staged those files. So let's go ahead and set up Spire with that token.
Probably also worth pointing out that in a real production setup, you'd be pretty unlikely to use join tokens for this. For a demo, they're great because it sidesteps a bunch of organizational questions about how you would do this in the real world. For production, not so great.
That's right. Okay, Spire's up. Let's get DNS. Exact set of commands here.
Excuse me.
Next time I'll stage the binaries on the machine too, so we're not watching this download, but it just takes moments longer.
It's actually really weird to me that Azure would, that this would be slow on Azure, right? It's like, hey, come on, guys, you're a hyperscaler. You should be able to download this stuff really, really fast, right?
I'm gonna avoid saying anything at this moment. Next step is adding the same two Windows firewall rules to allow inbound traffic. And now we're going to create the external workload on the cluster again for the color workload. We got the dash in the right place this time. All right, good.
Always a good sign.
And let's go ahead and install that service on the Windows VM. Once I find the right one. Again, same script. We're just differences. We're installing color instead of smiley. And again, this will download from GitHub, wrap it up in a manifest for the Windows service, and great. Next step, we're going to grab the MSI, just like we did before. Just curl it down from GitHub, and then install it with the color group name that we just created. And this time we installed it with a passive flag to the MSI, so that's why you're seeing the pop-up here and the installation process. That's nice because then you know when it's done. But yeah, obviously, you can just script that as well. And let's see, how are we looking here? Nothing yet, but we should see this in just a second, unless I missed something, which is always possible.
Doesn't seem like you did. That particular step can take a little bit because it's doing a certain amount of network plumbing, but then there's also timing on when the harness will start to notice that the external group has external workloads associated with it.
Yeah, let's take a look at
I actually said that wrong. The external group, the code behind the external group has to notice that there are endpoints available, at which point it will go and create the external workloads.
That's right. Let's take a look at that real quick. Let me grab the right commands. Let's see. Okay, color is up. Color's up.
It's working.
Okay. Yeah, I've seen that work faster and slower at times, and
there's a big eventual consistency piece in there, so it can take a minute or so.
Yep. Okay, how are we doing? We still have a few minutes, I think.
We have a few minutes. We can, I think we have enough time to show moving the GUI over if we do it quickly.
Yeah, let's try and do that. That's an important piece because up until now, these workloads running on Windows, they're using the traffic that's coming from the mesh is coming through the inbound listening port to the proxy directly, and then being processed by the proxy, and then eventually handed over to the Faces services. We're going to show when we install the GUI on the cluster is the opposite side of that, is the GUI reaching out into the cluster and showing those services, and that's the part that actually uses the redirection of the network driver,
Right.
which is the missing component that we built for this Windows Mesh expansion. So I think we can get through this in the next couple of minutes, going so well so far. And the other nice thing about this is I'm going to run I'm going to move the GUI over to a Windows Server Core installation, so you won't have to look at the Windows desktop anymore. And so we're going to go through mostly the same process that we just did. Here, this is where it's showing. Let me pull up. This is a Windows Core virtual machine. Here, we can show you a couple things about this. I meant to do this before, but we can see that we're running Server 2025 in the Server Core installation type, and the secure boot is turned on. Let's go to our Spire server, create a new entry for this workload. Just like we did before, we're going to create one for the Faces GUI. And
I haven't mentioned this before, but it's worth pointing out that the parent ID and the SPIFFE ID and things like that, those actually do have to line up with values that you use for the external group and later. So,
okay,
not a hugely difficult thing, but worth pointing out.
And just like we did before, let's set up Spire with that token we just minted. Okay, and grab DNS. Okay, looking good there. We're going to add our Windows firewall rules. We're doing one thing differently on this side, which is we're opening up the port that the GUI is actually using, so we can hit this ourselves, and that's what this 8083 is here. So the other same two rules we added before for the inbound listening port from the mesh and for metrics, as well as one new rule. Let's create the external group in the cluster. Okay. Sorry, wrong tab. And let's install the Faces as a service on the server core machine. And as soon as this step is done, we'll be able to see the Faces app, but it won't be meshed. It won't be connecting to either Smiley or Faces. The one I'll switch to using this in the cluster. So sorry, on the VM, on the server core VM, there's a new IP address. I will send all you. 210.
Seeing those RC2 versions in there is making me kind of embarrassed that we haven't tagged 2.1.0 final yet. I'm sorry
There's
about
work to be done yet. So this is the Windows Server Core VM, which is not meshed, which, as you can see, we'll eventually get timeouts here. But right now there they come. And they go away sometimes.
The browsers are a little weird in that they don't like making 16 simultaneous connections outbound. You get some really interesting sequencing of things.
Yeah. Interesting. I never knew exactly where that was coming from, but
That's where it's coming from.
So as we download the MSI for Windows Mesh expansion and install it, we should see basically that that grid get filled out and start working. Soon.
Yeah, and again, we expect this to take a little bit of time. Hey, there we go.
Not even that long this time.
Yeah. And since the connections are working quickly, we don't get those really weird delays, right?
Exactly.
Yeah. Nice. So in this case, your web browser is talking to the GUI workload, which is an HTTP server, running on your VM, which is then reaching to the face workload in your cluster, which is then reaching back out to Smiley and Color on separate VMs. Nice.
That's right. Yeah, we've got a whole round robin of Windows VMs talking to each other through the mesh.
Doing this in the most complex way possible. Awesome.
Just to show you what's possible.
Yep.
How much time we have? We have a couple minutes. There's one other, I guess maybe one last thing I wanted to show you, which is just applying a server policy using identity to disable some of these faces and keep some of them enabled. So right now we can see this is our in mesh, in cluster GUI, and this is the Windows VM one. We can apply a policy that will allow the cluster to keep working while denying connections from the VM based off service roles and identities. So just to see that in action, let's go ahead and create and apply a policy to do that. And so you can see here, we've got a cluster only policy for faces that uses an auth policy to require we're using the auth refs, right? Yeah.
Yeah. So we don't really want to go through all of this in detail, but if you look right in the middle of that, sorry, if you can go back there for just a second.
Yep.
Yeah. If you look right in the middle there, you'll see default.faces.service account.identity.cluster.local, which is the most relevant piece of this. That's the thing that is specifying which identities are allowed to talk to the server on the top. You define a server to talk about which traffic you want to control. You define mTLS authentications to talk about which identities are allowed to use that traffic, and then you define an authorization policy to link the two together to do that really, really quickly.
Good explanation. Thanks for that.
Yep.
Yeah. So, and then let's take a look at how this impacted the two GUIs we've got up. The in-cluster one stays server as we'd expect. While I said that backwards. That was the
in-cluster one is happy. Yeah.
Yeah. This is the Windows VM server core GUI that's been denied based off that policy, but the in-cluster one continues to work as we expect. And so we're seeing.
Go ahead.
Just a demonstration to show all of this working end to end through policies being applied based off identity.
And I bet you if you edit that mTLS auth to have the SVID string from the Faces GUI workload. I bet you these will swap.
Yep. Yeah, we could do it the opposite way around, and all of the plethora of features that come along with Bell and Linkerd, you now have access to on your Windows workloads,
which is really cool if you're running Windows stuff. All right. Well, we are just about at time. We can give it a minute or two in case anybody throws in any last minute questions. I don't see any right now. I'm going to go ahead and pull this down for the moment. So yeah, I think we can go ahead and call it. Thanks everybody tuning in. Appreciate it. Thank you, Kashif, for actually doing all the hard work here. I appreciate that too. And yeah, I think next month we're actually going to do a kind of a different format for Service Mesh Academy and talk about gRPC some.
Yeah, and if you guys, if anyone out there has more questions or interest about this, about Windows Mesh expansion, we'd love to hear from you.
Absolutely.
Use cases, any issues that you found in your own deployments, or things you'd like to see this do that might be useful in the future.
Yeah. All right. Thanks much. We'll see you all next month. Have a good one.